So now, in past few sessions, you are made aware of about the concept of signals and systems. What does it mean? Now, means it is a systematic study of the input and output signal when passed through a system. The system normally leads to a differential equation, and solution of these differential equations is not so easy. It involves a very complex process which I am discussing in tutorials. Sometimes we will elaborate it, but because of especially digital things coming into picture, what is the scenario today that I would like to elaborate very clearly. Have ever anybody of you came across bass and treble? Means that, see how the generational shift. Bass and treble are used to be the controls of your cassette player, radio set, music system. They provide different gains for different frequencies. Have you heard of equalizer? 5-band equalizer, 7-band equalizer. So when now camera is the perfect example of digitization. Like that, almost everything now. So this is now we are having an overview of signals and systems and how the things are transformed and on what exactly we should focus. Now almost everything is digital. Almost everything. Means earlier you have learned transistor in the first semester. Then you are learning op-amp currently. Then we are having a mic. We are having a speaker. So mic, amplifier, speaker is conventional system. So you talk, that is a pressure signal, converted into a voltage signal by the mic, applied as input to amplifier, converted into again voltage signal only, but with what we can say, depending upon the speaker and the strength you need, it amplifies, and that is again given to the speaker. Speaker produces actual sound. So that amplifier is the middle block. Then in that amplifier you add various RC components so that you can process these signals. Means mere amplifier is directly conversion, but you can give various sound effects. So that was various equalizers, and you could adjust the gains of individual frequency bands. All that thing was very complex because it required a huge op-amp based circuit. But what has happened now, because of easy availability of digital things and very fast processing CPUs, any signal what is available, the things available in nature are continuous. So that you convert into voltage signal. When we talk of signals and systems, is connected to electrical or electronics engineering in the sense that it is voltage is very convenient to be processed. So it is converted into a voltage signal. Once it is converted into voltage signal, it is sampled. Have you learned sampling theorem? Not yet, right? So it is sample means what? Instead of taking the total signal as such, its values at means, so this is very fundamental thing, and for that I also suggest, being electronics engineer, one thing you should do immediately in next few days, you Right. I hope that you are having separate notebook for each subject. Oh, the question is somewhat advanced question, and unless one answers the basic question, advanced question should not be asked. First is that, do you have notebook first? You write down this, and I will put its PDF also, but you write down what it is. A mathematical theory of communication. By C.E. Shannon. This is 1948 paper, which is still relevant today. It's 55-page paper, and what I advise is you spend 55 rupees and have single-sided printout of it. And in today's world, when everything is simple, Google makes the things simpler, at the same time it makes us handicapped. So what you should do, you take printout and then you should keep a practice that within every 15 days, in fact it should be, if the genius is not there, he would have limit would have 1 week. Every 15 days, you should read the paper once. Every 15 days, you should read the paper once. It is, means, see, that all terms are known. The terms which are not known, you can Google them. The first reading will take some more time, but subsequent readings would be somewhat rapid. And then you develop your own understanding of this paper. And at the end of the semester, you can write its review. So what you understood from this paper. This is a very basic paper and every electronics engineer must know it thoroughly. Only thing is that it can't be understood instantly. So it needs various, what we can say, iterations of reading. So you proceed for that. At least have a 50-page single-sided printout. So it is too heavy to understand, but you must, because being students of such a reputed college, having so much competency through which you have come to this college, it must be understood. If it is not understood, it should give pains to you. So that you should, and you can have interactive discussions also amongst you. It's not something which is in solitary confinement. You can discuss amongst yourselves and proceed further. But at the end of the semester, you should develop a clear understanding of this, what we can say, paper. This is relates to especially introduction. It is introduction to digital world, digital communication. That time when microprocessors, computers were not there, that time he has thought about it. At least we should understand it fully today. So what we do, so what happens is that a signal is in analog form and we sample it. So if this is voltage signal, right? Its time axis, that is actual voltage signal Vt. Now, instead of taking, when we take the signal as a whole, all values of it means all values of the variable which is mapped versus time are taken into consideration. Now, instead of considering all values, if I consider few values, what I will find? I will lose some information. If I take few values, I will lose some information. But if I take few values at very small interval, then the information loss would be negligible, right? So if I pick up, say, so this is called as continuous signal. This is continuous. The continuous signal, continuous function of time. Instead, I sample. When I sample, I decide to discard. So this is infinity lock. These are the points on this signal are infinite and uncountable infinite. Whereas natural numbers are infinite, but these are called as countable infinity. You can count them. You never stop, but you can count them 1, 2, 3 and so on. Whereas they are uncountable infinity. Then out of these uncountable infinite points, what I do? I collect few points, let us say at a sampling interval, let us say capital T. So at t equal to 0, at t equal to t, at t equal to 2t, at t equal to 3t, at t equal to 4t. I collect these samples. Right? And it is at, on this axis, so into capital T. So this is n equal to 0, n equal to 1, n equal to 2, n equal to 3, 4, 5, 6, 7, 8 and so on, right? So n is a natural number, or it can be a whole number, it can go backwards also, 0, 1, 2, 3 and minus 1, minus 2, it can go on either side. Then this Vt signal is converted into Vn, that is V0, V1, V2, V3. So, for continuous signal, the horizontal axis, that is time axis, was continuous, and vertical axis of voltage axis is also continuous. Whereas what we are doing? When we are sampling, we are discretizing. So the horizontal axis or time axis we are making discrete. And what is the amplitude axis or voltage axis? It is continuous. Remember that I would like, this theme is very important, that the sample, suppose if that I bring such few, these are of the manufacturing company, so the value would be same, but if suppose if that, listen very carefully, extreme care is needed. Suppose if that there is one factory, what I would like to give an example of discrete. There is one factory which manufactures cakes. So there is some procedure with which the cake is manufactured. So cake, and that lot is brought. So there are say 100 cakes. 1, 2, 3, 4. So it's a individually countable. And the cake is expected to be of 50 grams each. So weight of cake 1, cake 2, cake 3. Weight is a continuous function. When we say 50 grams, what 50 corresponds to? The approximate number to which the weight is close. Are you getting me? 50 gram weight, actual weight would be weight of cake 1, which is maybe near to 50 but not exactly. Or height, suppose if you prepare the chalk sticks, each will be having some height. How you can represent the height? The height to be represented in centimeters, where 1 centimeter is the unit, x centimeters. That x cannot be represented by digits. Listen very carefully, I am explaining a very important concept. Height of, this is a chalk piece, height of a chalk piece, how much is the height? X centimeters, where x is around 8 centimeters or 10 centimeters. Actually it is not. It may be 10.1. If you go for further accuracy, 10.11, 10.113, 10.1135. Exact height cannot be expressed by using digits. You can go on increasing the digits so that you are, what you express and what it is are different by negligible amount. So, listen, very important thing, value of any continuous variable when is expressed by digits, numbers, let us say decimal numbers, no need of going for binary, decimal numbers, it is approximation, right? Expressing value of any variable by digits, decimals by numbers 1, 0 to 9, maybe in decimal, using decimal format, is approximation, and that is called as digitization. That is called as digitization, and that can be supplied to a computer. Continuous system exists, an operation amplifier processes continuous signal in original form, does something, produces continuous signal. Whereas a computer, you take continuous signal, you sample it. This is discrete signal. So this value, this value, this value. The processing of discrete, there is an array, V0, V1, V2, V3. So V0 is a real number. A real number cannot be completely expressed by using digits. So it is represented by using variable only. So V0, V1, V2, V3 is real number. So real number processing can happen on paper, but it can't be brought in practice. Continuous variable processing happens on paper, can be realized by using the circuit components. Continuous when sampled. Now, in this sampling process, there will be some error. What that error would be? There is sampling time we will learn in other subject, but right now, what would be error? This is the error. So, value is this. Till this point, I can say this is the value. Value is this is the value. This is the value. So, the addition of areas, when I sample on downside, this is the area, right? So, area of these, are you getting me? So, if you sum those areas and over 1 hour, what is the addition of all those areas? Less the addition means less the error, right? So, or no need to go in that details also. Any signal, when you sample, right now, with the simple most example what I can give is that things which we see on video today. So it is continuous pictures are taken and those are transmitted. It is not that I watching actually and I watching something recorded. The difference is that in recording process, now already digitization is taking place. I listen something now. I listen something. In that also digitization has taken place. So the simple thing is that if I sample the signal at sufficient fast rate, then the error between actual and sample signal is negligible. Right now, at this stage, there is no need for us to think what would be its impact. Then these sample values is array. This array, or you can work on sets in 11-12. So the values of the components in the set are continuous and expressed by variables. This is real variable. This discrete time signal exists on paper. You can solve on paper but you cannot process it, you cannot realize it, because that will require analog computers. Analog computers in one era were available, but the digital computers have grown in such a faster pace that analog computers have become irrelevant. So discrete time signal processing cannot be practiced. So there are three components: continuous, actual implemented using conventional circuits. Discrete, what we do with discrete? We sample only on paper. Whatever we discuss, all these things will be on paper, can't be materialized, realized. And then you will say, oh, what kind of subject this is? We are talking something which can't be realized. But it's not so. Discrete, when digitized using analog to digital converter, digital signal processing, realized using computers. Computers, all kinds of processors in your mobile also, you are having all these things. So, what is this? Now, when you talk of any system in the world today, almost all, except few systems it may be, almost all systems contain what? What would be block? Block diagram. Block diagram would be actual signal. Is available. Then transducer. What transducer will do? In first semester you must have learned some subject. What transducer will do? Transducer will convert, say pressure signal is there, as we talk. But there may be some other signal also. Temperature signal. Transducer will convert all other signals into which signal? Electric signal and voltage, because that is somewhat convenient. That is voltage signal. That voltage signal is given to a sample and hold circuit and then ADC. That sample and hold circuit means take sample, hold it, convert it. So there is no need for that. We can say ADC, analog to digital converter. Now what? Now ADC, the real transformation has taken, I think, I don't know, I will spend this time, few minutes here. Electrical engineering and electronics engineering, what is the difference? So, because this is very fundamental, otherwise you are in the second year now. So, I will pause the video, allow recording, I will allow you to think, you answer, and then I will explain. So, those who are not watching will also think. And the difference is that you have to think here. You can think in vacuum with nothing in front of you, but if I make a pause for a person who is watching on recorded thing, it will be what we can say is not so friendly. So we pause and he will think and then play the next video. Presuming that you are playing these videos.